now that we have gone over the unit circle and identities and several things like that with trig functions, now we're going to look at graphing trig functions. So the first thing we're going to do is look at the sine function. Okay, I'm going to draw a quick little unit circle up here. Change that size of there. Remember the point out here was the point 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Okay, so let's just go through here this chart first, and so we can see some things, and then we're going to talk about all this period, domain, range, and all that stuff. So remember the sine is, remember it always goes cosine and sine, so the sine at 0 is 0. The sine at a half is 1. The sine of pi is 0. Sine at 3/2 pi is a negative 1. And the sine of 2 pi is 0 again. So when we start graphing these things, one of the critical things is you always have to label your units of measurements on your x and y axis. Okay, and since I have these points right here that I'm going to graph, I'm just going to start with those. 0, half pi, so this would be a pi, and this would be 2 pi. And going backwards, this would be a negative pi and a negative 2 pi. And going up and down, let's just go 1 and a negative 1. Okay, so the sine of 0 is 0. I'm just going to do this one, then I'm going to show you how I go about graphing these when it's not just the parent function like this. Okay, what we're doing right now is the parent function because there's no numbers associated with in front of or anything like that. So sine of 0 is 0. Sine at half a pi is 1. Sine at a pi is 0. At 3/2 pi it's a negative 1, and at 2 pi it is 0. So I'm going to connect the dots. Now it's not just straight lines, it's nice curves. So hopefully you can curve it out nicely. Something like that right there. Okay? Now that is what the sine graph looks like. Now it does not stop there. It keeps on going on forever and ever in both directions. Okay? But a couple of things here that I want to point out is from here, from 0 to 2 pi, it completes one cycle, doesn't it? Because then it's going to do the same thing, go up and down and up and down and up and down. So from here to here, that is called your period. How long does it take to do the full cycle? It's right there, and that's 2 pi. That's for the parent function of sine is 2 pi. Okay? Your domain is what can you use for x values? Well, I go on and on forever in both directions, so that's why it's the negative infinity to infinity. And I want you to see that the range is from negative 1 to 1. The lowest we go is a negative 1, the highest we go is positive 1, and that is your range, and it does include both of those. Okay, there's something else I want to point out to you with this is how high and how low it goes. And you can see from the center here, which is the x-axis, okay, that cuts that graph in half, kind of. From that to the top is called the amplitude, okay, or from the center to the bottom is the same thing, is amplitude. So you can see that it's 1 unit, for our case here, it's 1 unit and 1 unit, and that has to do with your range as well. It goes up 1 and down 1. So when I go over here to look at my box that I have here for the formulas, the A value, the number out in front, is your amplitude, and that's how high and how low it goes from that center axis of your graph. Okay, and that's like the vertical stretch, and we'll look at some examples of how that is affected. Your B value helps you find your period, which is figured out by doing 2 pi divided by b. And again, when we look at some more examples here with some numbers other than the parent function, a lot of this stuff will make sense. And then the C value, just like in every graph before, the number inside with the x, it makes it go left and right, and it's opposite the sign. So that's your horizontal translation. One key thing here is that you know that the b is factored out from there. And again, we'll get to that a little bit more with an example we have to show you. So then let's go and see how the cosine, or this is the sine graph. Okay. Now if I wanted to graph that, keep on graphing that all the way to, let's do a total of 2 periods, I can do that same thing going backwards. Okay. And the way I go about graphing these is I start my starting point. I know the period is 2 pi, so I'm going to count over 2 pi. Put it out there. Halfway in between these, you can see there's the middle point. So again, halfway between those. And then between these two, halfway, it's as high as it goes. And between these two, it's as low as it goes. So, if I was to graph that over 2 pi, it looks something like that. Okay? And again, we're going to do several of these together. So, let's compare that graph to the cosine graph. So we see that they are very, very similar to each other. So again, real quick, looking at the unit circle, that's 0.10, 0, 1, -1, 0, and 0, -1. Now the cosine values, remember it's all the x values, it's going to be 1, 0, -1, 0, and 1. So if I was to, again, let's count by the same units of measure. H1 is a half pi, so that would be pi and 2 pi, and negative pi, and negative 2 pi. You always have to include what your units of measures are, so we know what you're counting by. If you don't, then you can't count it right because we have no idea how big or how tall this thing is going. So, at 0, it's at 1. At half pi, it's 0. At pi, it's -1. 3/2 pi, it's 0. And at 2 pi, it's back to 1. Okay? Now that completes one full cycle again, because if you see, it goes down, all the way down, and then all the way back up. And we'd start that cycle again and just keep doing that same thing over and over and over again. So, my period here is still from here to here, because that starts and ends at the same place. Okay? So that's still your period. Your amplitude number is still, from that center, that x-axis there, as high as it goes or as low as it goes. And your domain is still a negative pi to pi because you still use everything. The only difference is instead of starting at 0, 0, it starts at 0, 1. That's the only thing different between the sine graph and the cosine graph. They look exactly the same, but it just looks like it's shifted over a little bit. Okay? So if I was to go over here, back to the box that's on the bottom of that page, you can see the sines over here and the cosines over here. There's nothing written under it because everything is treated the exact same way. The A is still the stretch, the period is still figured out by 2 pi over b, and the phase shift is still that C value. This should be a C in front here, by the way. That is your C value, is the horizontal shift, the horizontal translation. Okay? So, since we're only doing section 4 or 5 right now, we're going to skip over the tangent one right now, and we're going to go straight to example number 1, which is graph the function y equals 2 sine of x over 2 periods. So, let's first do this. Let's first find the period. And we find the period by doing, the period is, remember our formula is 2 pi over b. Now remember this is our, it always goes in the form a sine bx minus c. Okay. So our b value, the number with their x is just a 1, so that's just 2 pi over 1, which is just 2 pi. So I know my period is 2 pi. Okay. Let's go ahead and figure out the amplitude. The amplitude, remember, is the number out in front, and it's just the absolute value of that. So that's the absolute value of 2, which is just 2. Okay? So here's the way I go about graphing these things. First, we got to make sure we label our axes here. Since my period is 2 pi, I'm just going to count by, do what we did before, count by half a pi's here. So say pi and 2 pi, and negative pi, and a negative 2 pi. And then I'm going to count by 1s going up and down as well. Negative 1 and negative 2. Okay? So I know sine at 0 is 0. That doesn't get moved at all. And the way I go about graphing these things, and it works pretty easily, I think, go over your total period. Your total period is 2 pi, so I'm going to count over 2 pi and put my other dot there, because I know that's where I got to start and the end at the same place. Now we know with the sine function, halfway between these guys, which is at pi, is where it's got to cross the x-axis again, because we know that graph looks something like this. This is what we're shooting for. So we had the starting point and we had the ending point, and halfway is what we just put right there. Okay. Now halfway between the start and the middle is got to be your high point up here. Okay. So halfway between these is at a half a pi. We're going to go all the way up. Now normally it's just at 1, but this amplitude or this stretch number is stretching it up to 2 at this point instead of just 1. So it's making it twice as tall and twice as low. And then halfway between the middle and the last is your lowest point down here in the valley. So again, that's going to be your, normally be a -1, but it's going to be at a -2 right now. Okay, and then we just connect the dots. And make sure you have the nice curves going on, not these like absolute values. Okay. But we want to, that's just one period, that's just one full cycle, but it says we want to graph it over 2 periods, and of course if we kept going this way we're going to run out of room, so let's go backwards. So I'm going to count backwards 2 pi. Halfway between those is back at the 0. Now this is where we normally start now. So halfway between these is your highest point, which is at 2. Halfway between those is your lowest point, which is at -2. So we go up and down and back to where we started. And that is your graph for that function y equals 2 sine x. It graphs it over 2 periods, because here's 1 period from there to there, and there's 1 period from there to there. So that's my 2 periods, and I've graphed that whole entire function now. Okay, now we're going to look at example number 2, which is y is equal to 1/2 the cosine of x. So the first thing we're going to do is look at our amplitude and period, just like we had on the other ones. So let's just lift those out over here. The period for these for cosine is 2 pi over b. So that goes to 2 pi over, now remember my b value is the number that's inside there, so that's just with 1 again, so my period is 2 pi. And my amplitude is the a value, the number out in front, which is 1/2. So this, instead of going up to 1 and down to 1, now the amplitude is half, so it's only going to go up to 1/2. Okay, so I'm still going to label this 1 and -1, just so we can see how that is in relation to the other ones that we graphed. And 2 pi, so I'm just going to go to pi and 2 pi. And backwards is the same way. So make sure you always label those. Now, cosine at 0 is normally 1, but we have our amplitude of half, so it's not going to go up to 1, but it's only going to go to 1/2. Now, we go over our period, which is 2 pi, so we go over 2 pi from there, and we're right back to where we started. So we have to be somewhere around there. Okay. Now remember, cosine starts up on top of the hill and goes down in the valley and comes back up to the top and starts that process over, right? So we've gotten those 2 points there. Now we need to get halfway between all the way down to the low point. So halfway between those is pi, and it's all the way down to the lowest point, which is normally 1, but our function, the amplitude is 1/2. Color these blue so we can see them easy. So it's going to be at 1/2 this time. Okay. And halfway between the high and low has got to be right in the middle, so that's right there. Okay, do the same thing going backwards, go all the way over 2 pi. Halfway down is the lowest, and halfway in between those is your middle points. And there's your graph. Pretty simple there. If I can graph a good curve here. Oops, got the idea there though. Put these on your paper. There we go. So that's what the graph looks something like that. Now we're to number 3, graph the sine of x over 2. So I'm going to rewrite that as sine of 1/2 x. So we know that's my b value now, so we're going to change up our period finally here. So our period is 2 pi over b, which is 1/2. 2 divided by 1/2 is the same as 2 times 2, so that'd be actually 4 pi. And your amplitude is going to be, the amplitude is just the one out there in front. Okay. So now where we're going to start that graph at? Well, sine at 0 is normally 0. Sine at 0 is 0. So we start there. Whoops, forgot to label our axes, right? So always do that first. Don't forget. So I gotta go up to 4 pi this time, so I'm going to count by pi's. If I don't, I'm going to run out of room real quick. And going back, the same thing. And you don't have to label them all. Just make sure I know what you're counting by. And again, I'm going to count by 1s going up and down. Okay? So now, the period of 4 pi, so I start at 0. Go 4 pi over, I'm back to 0. Let me change that color again so this sticks out. Halfway between those is your middle. Halfway between those guys is as high as you go when our amplitude didn't get changed at all, so we're still at 1, and halfway between these guys is a -1. Same thing going backwards. Go 4 pi back. Halfway between those. Halfway between our first and the middle is going to be the highest point. Halfway between the second half there is your lowest point. And there is our curve again. Our nice sine curve. So you can see what's happening here. Whoops. As I messed that curve up. I was doing pretty good there too. So you can see normally it's from 0 to 2 pi, but now it's stretched out from 0 to 4 pi, so we got twice as long by putting a 1/2 there. Now moving on to question number 4, which looks a lot more complicated. It has 2 pieces in there instead of just 1. So let's look again at our period. Our period, the b value still is 1, so that's just 2 pi over b, or just 2 pi. My amplitude, the number out in front, which is 1/2. Now what does this number represent right here? Remember, that's our phase shift. Our phase shift, which is our horizontal, so it's going to go pi thirds to the, remember if it's negative it goes to the right, just like everything else, it goes opposite the direction. Okay, so we got to move everything, shift over everything a pi thirds to the right. So I'm going to go through here and add a couple more lines on. I'm just going to cut these in half so I can easily tell, because I'm going to need more than just what's there. Okay, so I'm going to do every line as a third of a pi. So that means that's a pi. 1, 2, 3. This is 2 pi. Go back. 1, 2, 3 is a negative pi. 1, 2, 3 is a negative 2 pi. Okay, and I'm still going to go up to 1 and down to 1. Okay. So now when I graph this here, pi of the sine of 0 is normally 0, but what happens? We have to shift that over a third of the pi to the right. Okay. And what I tend to do a lot of times, I like to draw in a dotted line. Let's see if I can get my dotted line here. I like to draw a dotted line in there. Remember, that just kind of helps me remember my x and y axis get shifted around. So that's where my new starting point is now, right there, instead of where it was over here at 0, 0. So I'm starting here now. Subtract the blue so it sticks out. So that's my starting point. So I'm basing everything off of here now instead of over there. Excuse me. So I go over my period, which is 2 pi. 1, 2, 1 pi, 1, 2, 3, that's 2 pi. Halfway between these is 1, 2, 3 right here. So that's back at the 0. And halfway between these guys would be that 1.5. Now we're going to go all the way up, but we're not going to go up to 1 because our amplitude is now 1/2. So it's going to be somewhere around there. Halfway between these guys is the 1.5 here. So that's going to go down to somewhere around there. Same thing going backwards, and this is where you got to be careful when you count backwards. make sure you count from here, not from your origin. So 1, 2, 3, 1, 2, 3. So there's where the starting point is. There's the middle. Halfway between those guys would be your highest. Halfway between these two guys would be your lowest. Okay? So if I make this curve look nice, not mess it up too bad. And there's your curve for that function. Not bad, just make sure you do that shifting, and always put that dotted line. It's not like your asymptote, but it's just kind of there to help you graph so you don't screw things up. Now to question number 5. This one looks even more complicated because it has some extra stuff in there. The first thing I notice is that b value is not factored out. That b is in there with the x, and I need it out in front of here. So that's the first thing we've got to do. So maybe write that as -3 cosine. To the x by itself, I got to factor out the 2 pi between both of those. So if I divide both of those by 2 pi, I have x. Divide 4 pi by 2 pi would give me a value of 2. That's the equation I want to use to figure out my a, b, and c value. Okay. So my a value is -3. Let's start with that period, like we've been doing. Period is 2 pi over my b value now, which is 2 pi. So those actually all cancel out just to a 1, which is very different from what we've been doing, because normally our period is in terms of pi, but now it's in terms of just 1. So it makes it a little bit easier maybe. Amplitude is 3. Make sure you don't put the negative. If I was asking what the amplitude is, it's not a negative. Remember, it's always the absolute value of that number. So the amplitude is just 3. And your phase shift on this one is 2, and it's a positive, so it's going to go 2 to the left. Okay? But what does that negative mean? That negative means it's going to be reflected over which axis? If it's negative out in front, it's going to flip over the x-axis. Okay? So let's figure out how this thing is going to look now. Okay, so let's figure out what we're counting by first. My period is 1, so now I'm just going to go, let's just count by ones here. 1, 2, 3, 4, -1, -2, -3, and -4. And going up and down here and count by ones again. 1, 2, 3, and so on going down. Okay. So now let's look at see what we can do here. I'm going to go ahead and draw my dotted line in there so I don't get myself mixed up on that where I'm at for my y-axis there. It said I'm being shifted over 2 to the left. So my new y-axis is really going to be over here now, isn't it? Okay. So I just put that in there to help me. If you don't want to do that, that's fine if that just messes you up. But I know I'm not basing everything on here. Now I'm over here. I'm starting out everything over here. So cosine is 0 is normally 1. So I'd normally go up here to 1. But the 3 means I'm going to be at 3 instead of at 1. And the negative means I'm not going to be at a positive 3, but I'm going to be down at -3. So let me get a different color. -3. So that's where my starting point is there, because I start back here because I got shifted 2 to the left. The amplitude is 3, and it's flipped over the x-axis, so I got to go down to a -3. Okay, so my graph is really going to be like here, and since it's flipped over, I'm starting at the bottom, I'm going to go to the top and back to the bottom. That's what each period is going to look like from here to here. Okay, so I've got to look and see how far my period is. My period is just 1, so I'm going to go over to 1. I got to be right back to where I started from. So this one's going to be nice crammed in there. Okay, so if I go halfway between here, halfway between the two low points has got to be the highest point, doesn't it? So halfway between there, at the half here, is going to be all the way up to the top. And then halfway between those is where it's going to be back on the x-axis there. Make sense? Okay, so let's just do the same thing. You can either go backwards or forward. It doesn't matter. I can still go forward in here, so I'm just going to keep on going forward with it. So make sure I graph it over 2 periods. I'll go over one period, go halfway between those, somewhere around here, go all the way to the top, and then your middle points are right there. Okay? So you can see that this one doesn't take nearly as long time to get up and down your hills. And your graph will look something like that. Okay? Let's go on to question number 6, which is the last one for sine and cosine. We have that 3 plus cosine. We normally write this like this, because we normally have that number that's being added or subtracted in the back. So that looks like every other thing else, where that number in the back just makes it shift up and down. So that is your vertical shift. So let's list out the things that we know. Let's do our period again. Our period is 2 pi over my b value. My b value is 2. So 2 pi divided by 2 is pi. My amplitude, number out in front, amplitude is 3. Phase shift, there's no number being added or subtracted, so it doesn't get affected. And my vertical shift now, my vertical shift is 2, and that's which way is that going? It's going up 2. So let's first say what we're counting by here. Period is pi, so I'm just going to stretch it out nice. That's pi, 2 pi, and negative pi, and negative 2 pi. And counting up and down, I'm just going to count by ones. 1, 2, 3, 4, and 5. This stupid pen. There we go. So, since we have a shift going on there, I'm going to draw my dotted line in there just to help me out. The vertical shift up 2, so my new x-axis is now going to be... Whoa, that was the wrong funny line there. Let me take that off. Go to the dotted line. My new one, there we go. My new x-axis is going to be somewhere around there, isn't it? Okay. So that's going to help me graph. Now cosine of 0 is normally 1, so 1 up from that dotted line would be there, but our amplitude is 3, so I got to start up here. And let me change that color again so it sticks out. So that is 3 units up from there, and remember cosine normally starts on top and goes all the way down and back to the top like that. So we have to go our full period over. Our period is pi this time, so I'm going to go over pi. Got to be right back to where I was. Okay, halfway between those is your lowest point. Halfway between those is the half of the pi there, and so we got to get as low as we're going to get. Well, we got to go 3 down from our dotted line, so it's 1, 2, and the line there would be 3 right there. Halfway between these, we're back on our x-axis, the same thing there. Okay, and I'm going to just do the same thing. You can either go forwards or backwards, it doesn't matter. I'm just going to go forward with it, back 1 pi over, that's my period. Halfway between those is the lowest point, and halfway between those guys are the zeros. So then we graph it. And there we go. And that wraps it up for graphing sines and cosine functions.